Hello and welcome. My name is Barry Morris. I'm a general manager in the AWS Databases Group, and I'm here to give you an introduction to our AWS Databases portfolio and also to talk about modernizing your data infrastructure. I'll be pleased to welcome Mike Welch a little later from Verizon Media to talk through how Verizon have been using our data infrastructure for their needs. Let me start with the obvious question, which is why modernize? And really, this comes down to the question of making data-driven decisions. All organizations, large and small, need increasingly to be making decisions that are driven off data, whether those decisions are product development decisions or customer engagement or marketing or sales, strategic decisions, operational optimization. It's all about being more and more data-driven. And if you're not being data-driven and your competitors are, you might have a tough time in the market. So it's all about the data, and data is increasingly an organizational asset, and that will continue. Beyond that, it's also about that data being made available to all of your employees, because it's no longer a case of a few analysts in a corner looking at the data and analyzing it. It's really about every single employee making whatever decisions they're making on a day-to-day basis that way. And that means access to the data, and it means access to the tools that give you meaning to that data. And so thirdly, it's really about having those modern analytics tools and AI and ML and so on in order to be able to make sense of that data and make these thousands of decisions across your organization to drive a modern business. And the question is really, what does it take to do that? And of course, historical data infrastructure hasn't been well suited to that. And so the question becomes, how do you modernize your data infrastructure? And I want to talk about how our approach in AWS for doing that. There are really three pieces to it. The first is about what we call managed services. So databases as a managed service, the essence of which is that we take care of all of the sort of mundane work, and you get to do the things that are valuable to your business. The second piece of it is around the idea of having a portfolio, a number of different database services, which we call purpose-built for all the different use cases that you've got. And we'd like to spend a bit of time talking through those. And then thirdly, the topic of getting your data onto these services, which is a migration challenge. And it's a significant one that people are concerned about. Their data is valuable. How do I get my data and my databases onto the AWS services? And we've invested significantly in mechanisms for doing that. So those three things, which I'm going to talk through. The first of which is around managed services. And really, if for anyone that's owned and managed databases historically, you'll know that it's very expensive and somewhat painful to do all the database administration and the system administration, provisioning machines, creating sort of patching software, expanding capacity, all of these things, not to mention security issues and compliance issues and so forth, is all very costly and painful and is undifferentiated. It's not something that's adding a lot of value to your business. What adds value to your business is using that data, getting close to that data and understanding that data and making decisions based on that data. So undifferentiated heavy lifting is what people have historically done. And the point of managed services is that that's a core competence of ours. We know how to do that heavy lifting. We've moved hundreds of thousands of databases onto the Amazon cloud and have run them, and we know how to do that, and we're good at it. And managed services allows us to do that stuff, and you to focus on the things that you're keen on doing, which is taking care of the value for your customers. And so not only are the sort of somewhat mundane tasks of database administration and so forth taken care of, but also elastic cloud benefits, the ability to be able to press a button to expand your capacity or to move to a new location or to expand the system out and so on, to integrate with our services and third-party services for doing analytics on your data. All of those are sort of positive contributions on top of the fact that a managed service in the first place minimizes the amount of undifferentiated heavy lifting that you're doing. So if the first aspect of our approach is around managed services, the second is about the breadth of different offerings that we have. And of course, SQL is at the center of that. If you look at old guard commercial databases, there are challenges getting those databases to deliver the kinds of modern services that we're talking about. First of all, they're proprietary and therefore tend to lock you in, and it's hard to move away from them. They have punitive licensing, and they can be quite expensive. And so a lot of customers would much rather use open source products with open source economics. But there's a challenge with those, which is it's hard to run those with enterprise levels of quality of service. And so that combination is something where we can help, because we have the skills, we have the abilities to take those open source products and deliver open source services with open source kinds of economics in delivering SQL workloads. And so therefore, we have Amazon Aurora, which is an enterprise class database as a service. We have measured our MySQL version of Aurora to be 5 times more performant than the standard MySQL. Our Postgres engine to be 3 times more performant than the standard Postgres engine. We do that with all of these multi-availability zone, durability, and the other characteristics of this enterprise characteristics with Amazon security and so forth. And we do it at often a tenth of the cost of a commercial database for doing exactly the same thing. So Amazon Aurora is very much the way to run your enterprise SQL workloads on the cloud. One customer that I'd like to just mention here is Samsung, that have taken a very large application, as you can see, over 1 billion users, off of Oracle and onto Amazon Aurora. Major undertaking. It took about 18 months. We helped them with that. The headline is that they reduced their monthly database costs by 44%. And obviously that's an enormous win. Additionally, and you can see that a mention here of that the performance is really quite good. 60 millisecond average latency for over 90% of the queries, and to the comment that the architect makes on this slide, you'll see saying that, oh, and by the way, significantly reducing operational tasks, which talks again to the managed service that we were mentioning before. Now, of course, in the modern world, SQL is not the only thing. Developers are building a lot of other kinds of applications using other databases, which might have different kinds of data models, might have different query languages or different kind of access patterns, certainly have very large data sets and high performance requirements. And often in the context of microservices, where a microservices application might have multiple of these database systems. And so beyond SQL and relational, we have a number of other systems which I'd like to just briefly take you through. DynamoDB is a key value store designed for very high performance, global, scalable access to data. It's very fast to access it. Doesn't have a powerful query language like SQL, but you can get at your data very fast. And Dynamo is broadly deployed across many customers in AWS. Elasticache is an in-memory store and used typically for caching. It's for applications where durability doesn't matter, but speed does, and used a lot for caching applications. Neptune is a graph database for applications where connectivity between data is as important or more important than the data itself. There are many modern applications that behave like that. Amazon DocumentDB is a MongoDB compatible JSON database that can scale from gigabytes to terabytes seamlessly and transactionally. So if you've got enterprise JSON workloads, then that's where we would recommend that you go to. TimeStream, for its part, is a time series database at very high scale, petabytes of data, trillions of data points being ingested every day. That's the sort of thing that you can do with that, and it's used a lot in IoT and similar kinds of applications. QLDB is a ledger database for modern transactional kinds of applications. Keyspaces is a Cassandra-compatible database. For wide column kinds of applications. So what you're seeing is we've been building these kind of purpose-built database systems for a wide variety of different use cases, so that you can bring whatever use cases you have to the cloud. Let me talk to Pokemon as a customer. Pokemon Go is an application that, believe it or not, grew to 300 million users in a couple of years. They decided to move this application onto Amazon Database Services. They're using 3 of them: Aurora and DynamoDB and Elasticache. And as you can see, in doing so, they were able to reduce the number of nodes that they're running on from 300 to 30. And they were able to reduce their monthly database costs by tens of thousands of dollars. That's typical, by the way, that modern applications would use multiple database services in that fashion. The third of the major legs of this approach is really about DMS and data migration, database migration. DMS is the technology that we use. It's a sort of a self-service way. You can come along and take your database and migrate it to Amazon services yourself. But we also have our own professional services team. We have partners that help with this if that's what works in your situation. And we have multiple programs, including the Database Freedom Program and others, that we can point you at and recommend that you use in your migration. Once again, migration of your databases, we understand, is a big challenge and an important challenge, and something that you don't want to get wrong. And we're there to help you. Just to talk to DMS, the number of DMS-based migrations that we've done is well over 350,000 to date. So you're by no means a pioneer in doing this. And we've got many thousands of customers, obviously, hundreds of thousands of customers that have been through this. So they include some of the customers we've talked about, Samsung and Verizon, but also Expedia and Experian and Dow Jones and Bristol Myers Squibb and others. There are many customers that have done this, and we can point you to them if you're interested. So just to summarize, what we're saying is that we all want to have data-driven businesses. The way to build data-driven businesses is that you need the infrastructure to support that. We at AWS Databases have got an approach which has these kind of 3 major pieces, which is that they're managed services, that they're purpose-built databases that are designed for use for whatever your use cases are, and that we've invested in migration technology and services to help you to get there. There are plenty of resources online for you to have a look at, and here are some of them. I recommend that you do that, and particularly that you might want to look at our database blog. But at this stage, what I'd like to do is to hand over to Mike Welch, who is Director of Software Development Engineering at Verizon Media, and for him to tell us what they've been doing in using Amazon databases for their needs.
Thank you, Barry, and thank you everyone for joining us today. I'm Mike Welch. I'm a Director of Engineering with Verizon Media, and I lead the Yahoo Knowledge Graph engineering team. Today, I'm going to give you a few highlights of how teams across the company have utilized AWS databases and services to build and scale some key features of our products. Then we're going to dive a little bit deeper into how our team has migrated a core component of the Yahoo Knowledge Graph serving infrastructure to Amazon Neptune. So let's start with push notifications. They're important for engagement and one of the most effective ways to make sure our users are delivered relevant stories in a timely manner. About 2 years ago, teams started to look for ways to improve the push notification system across Verizon Media. They needed highly reliable, scalable services. At a peak, they needed to push to nearly 500,000 devices per second. But these events are also bursty, so the team didn't want to have any waste and over-provision just to meet that peak demand. The team settled on an async architecture utilizing Amazon's Elastic Cache, SQS, and DynamoDB. Today, the system powers push notifications across Verizon Media products. Next, we'll look at BlueJeans, which is a cloud video meeting service owned by Verizon. They saw enormous growth in 2020 as many face-to-face interactions were being replaced with online meetings due to the COVID-19 pandemic. BlueJeans was primarily running an on-premises infrastructure, which quickly reached its capacity. Procurement for new hardware in our data centers could take several weeks. The team had already been utilizing AWS for overflow capacity, but with these new scaling challenges, they decided to move to a cloud-first strategy. They worked with AWS teams to triple the capacity across the globe in just a few weeks. The database services were migrated from an on-prem MySQL to Amazon Aurora. The team also modernized their applications to use microservices and containers with Amazon EKS. As a result, the platform was able to scale and support the 5x increase in daily users they saw during the peak of the pandemic compared to their pre-pandemic levels. And along with it, they saw a large increase in the customer base and sales. So those are just a few examples of teams from Verizon and Verizon Media which have scaled their infrastructure by moving to a managed service and databases on AWS. But now I want to dive a little bit deeper into the details of how we came to utilize Amazon Neptune as the database in our graph serving infrastructure. Before I do that, though, let's start with a very quick overview of what is the knowledge graph, what data does it capture, how is it built, and how is it used throughout Verizon Media. So the Yahoo Knowledge Graph is a knowledge base of prominent real-world entities across multiple domains, like entertainment, finance, sports, events, and travel. Nodes in the graph represent the entities, and the edges capture relationships between them. Behind the scenes, the knowledge graph data is used as a key data source for systems and models for text understanding, query interpretation, content recommendations, and advertising. But today we're going to focus on more of the online real-time use cases across Verizon Media, where knowledge graph content powers entity experiences and products from search to news to entertainment and more. The knowledge graph is built on a large Spark cluster on Grid. There's 4 main steps to building the knowledge graph. First, we acquire data from sources all across the web. That data is cleaned and then normalized into a common schema. Each source then forms its own source-specific graph. Next, these individual source graphs are reconciled into a common graph. This is the process of determining which nodes in each graph represent the same real-world thing. After reconciling the source graphs, data is combined to build a richer, more complete view of the entities and relationships than any one source could provide. Lastly, this unified graph is exported in various formats for use by internal tools and teams and our own serving infrastructure. Producing a rich entity experience for users requires displaying data from multiple nodes in the graph. Details like the cast and crew, critic reviews, user ratings, and content links for a movie are all separate nodes in the graph, connected to the movies node through various paths. Historically, part of that export process was to pre-collect this type of information and persist it in a subgraph view for each entity. The serving system was then a relatively simple one. Given a known ID or alias for an entity, the pre-computed view could be fetched from a key value store and returned to the client. There were concerns at the time that anything more complex would be prohibitively slow. This has several disadvantages, however. Any online traversals of the graph would require clients to retrieve data, parse out IDs, and then make subsequent calls. And if the information the client wanted didn't happen to be part of one of those subgraph views, they would have to add it and wait for an offline process to run and the data to be reindexed. It was also not possible to execute true graph queries over the existing serving infrastructure. That was the state of things for some time. Then a few years ago, our team began looking at additional ways to utilize the knowledge graph content. One of the areas we focused on was question answering. Prior to us, other teams had built rule-based systems for question answering. They utilized those existing pre-collected views and essentially would identify which attributes or relationships they could extract as the answer to a question. This approach would work for simple questions, but it couldn't answer complex or nested questions. So we took a different approach. We built a system to transform natural language questions into abstract subgraphs of our knowledge graph ontology. Then these abstract graphs can be transformed into a graph query and executed against a graph database to find you the answer to the question. We settled on Sparkle as that graph query language. Then all we needed was a graph database to index the knowledge graph content and execute those queries. So we launched this feature on Yahoo Search in 2018. But a relatively small percentage of web search queries are answerable questions. and the relevant graph content was updated infrequently. So managing a small cluster of our own graph database machines in a data center was feasible to start. After we launched that, we started looking for how to solve some of the other issues in our existing serving stack. In particular, we wanted to reduce the friction that new customer teams had trying to find the data they really wanted. All of our data was now available in a graph database in a production environment, but the RDF data model and SPARQL language are not particularly user-friendly and make it difficult for most clients. So we looked and we settled on GraphQL as a simpler, more intuitive language for our clients. We built a GraphQL API for knowledge graph content on top of that existing graph database and other internal services. When we made this available to teams in the middle of 2019, it quickly caught on, and several teams began engaging with us and building on top of it. All this new API traffic increased the pressure on our graph databases, increasing our read traffic by almost 8x. It also raised the severity of any incidents on the infrastructure if they occurred, with many products now being impacted. As the traffic grew, we realized that a self-managed database would become a problem, and we engaged with the Amazon Neptune team to evaluate that as a possible replacement. Then in early 2020, the Knowledge Graph team began collecting country, state, and county level COVID-19 statistics for use across Verizon Media products. The Yahoo Search, Finance, News, and Weather teams all consumed this data from our APIs, and it quickly led to a huge surge in traffic. Much like the BlueJeans case, we couldn't simply add enough capacity in our on-prem graph databases to scale quickly enough. To make matters worse, our data was now also updating hourly instead of previously daily. This increased the pressure even further on those machines. Our API performance began to suffer, and our team began to spend most of our time fighting fires in the infrastructure. Having previously evaluated Amazon Neptune as a replacement, we knew it checked a lot of the boxes that would solve our infrastructure problems. We could easily scale that read traffic with the push of a button, adding more replicas. It also handles all of the data replication when you write with millisecond level latencies, which eliminated issues that we were seeing like inconsistent or stale reads across the replicas. We knew it was compliant with standards like SPARQL, so migration would be fairly simple. And of course, it's integrated with all the other AWS services like load balancing, monitoring, and alerting, everything that we were going to need for a production environment. It turns out Neptune was nearly a drop-in replacement for our existing solution. The majority of the work needed to migrate was on the content indexing side and how we would get data from our grids and data centers into S3 so it could then be loaded into Neptune more efficiently. Within a few weeks, we were able to rework our production pipelines to push our data into S3 and update our indexing process to run in EC2. With all of that in place, we set up a hybrid cloud serving environment on the west coast of the US and ran a bucket in production to compare the Neptune-backed GraphQL API with the existing production system. After a few days of evaluating on real traffic, we made a full switch to use Neptune 100%. We utilized some of the basic Neptune features like snapshots to quickly replicate our database to other regions and ramp them up. So within a few days, we were up and running in every region we needed. All in all, it took about 3 weeks to completely move our self-managed graph database system to the fully hosted system on Neptune, and the team could go back to focusing on our product and our customers. So we've been serving our GraphQL API traffic and question answering traffic out of Neptune for about a year now. Where globally, we're in 5 different AWS regions, and we're handling an aggregate of about 1,000 read queries per second. So for me, some of the key lessons we learned over this last year of working on our serving infrastructure has been, first, you have to really periodically consider your past limitations. In our case, 5 years ago, it was thought that handling high volume, low latency online graph queries would be too costly. This really limited our ability to build the type of services that our users and customers really wanted. Second, we had to be careful to evaluate the product needs and use the right tool for the job. We have graph data, and a graph database is purpose-built and optimized for the types of queries that we wanted to execute. Along those same lines, we had to be careful and use a spec like RDF and SPARQL as opposed to some proprietary stack. That made our ability to migrate to a managed service like Neptune much simpler. And lastly, the move to a managed infrastructure was a huge win for our team and our productivity. It allowed us to focus on innovating and using our expertise to do what we do best, instead of supporting and managing some of the basic building blocks. So that's it for me. Thank you very much for having me here today. If you have any questions, please feel free to reach out to my email, and now I'll hand it back to Barry to close out.
Well, thank you very much, Mike. That's fantastic to hear how you're using our database services to support the Verizon Media requirements. I would like to just point out that we do have training and certification opportunities around our databases, including digital online courses, including classroom training. We have certifications, and if you'd like to become certified in AWS databases, we have a way for you to do that. And we have labs and white papers and other things online. We have the URL here for you to follow up. With that, I would like to thank you. Thank you for attending, and thank you again to Mike for his contribution from Verizon Media. And I would like also to just request that you do take the session survey. We're very interested in your views on how this has gone and what was valuable to you. So please take that survey. Thanks very much.